This is a plastic bag. It is of course made from plastic. This is a mouse, also made from plastic. And this container, also made from plastic. There are so many things in our life that are made from plastic. Grocery bags, plastic wraps, food containers. But do you ever think of what happens when they serve their purpose and when we throw them away? Most of our plastic waste are products designed to be single-use. Every day, about 1 million tons of plastics are thrown away. That is roughly the weight of 11,000 blue whales. According to the role of plastic chemical recycling processes in a circular economy context by Qi Liu, only about 10% of it are being recycled. The rest is either burnt in incinerators, buried in landfills, or left for breakdown in microplastics in our soil and water systems. About microplastic, plastic will undergo degradation by sunlight, waves, and physical weathering. This shreds it into tiny particles less than 5 millimeters long. That is why we call it microplastic. It will then get absorbed by microbes through the food chain, eventually end up in our food. But how do we prevent this from happening? There are 3 ways to do it. First is plastic recycling. Recycling has 2 kinds of mechanisms. The most common way is mechanical recycling. This is the standard process used for our daily plastic waste like PET water bottles or HDPE milk jugs. The plastics are sorted, thoroughly washed, threaded into flakes, melted down, and extruded into tiny pellets. These pellets are then sold to manufacturers to make new products. This looks promising, but the catch here is that every time plastic is melted, its polymer chains degrade, meaning it can usually only be mechanically recycled a few times before the quality becomes too poor. The second mechanism is chemical recycling. Instead of just melting the plastic, chemical recycling uses heat, pressure, or chemical solvents to break the polymer chains back down into their original raw monomers or basic petrochemicals. This allows the plastic to be purified and rebuilt into brand new, virgin quality plastic infinitely. It is highly useful for hard to recycle items like mixed plastics, pouches, or food wrappers. The second way is to use biodegradable plastics such as PLA. This is the most common biodegradable plastic, but to decompose it will require industrial composting facilities. These facilities maintain high controlled temperatures, high humidity, and specific microbiome environments to fully break the material down into water, carbon dioxide, and biomass within about 90 days. Newer bioplastics such as PBATs are certified to break down at much lower temperatures found in a standard backyard composite bin. These typically decompose within a few months, leaving behind no toxic residues. The last method involves recent research around biological and enzyme degradation. In 2016, scientists discovered a bacteria named Ethionella sacchinensis outside a recycling facility in Japan. It evolved 2 specific enzymes that allow it to break down and feed on PET plastics. Scientists have since engineered these enzymes to work incredibly fast in industrial labs. These super enzymes can completely dissolve plastic bottles into their base components in a few hours. The process operates at lower temperatures than chemical recycling, making it much more energy efficient, eco-friendly option. We talk about many kinds of recycling methods in this video, but the most effective way is just to cut down our usage of plastic products. Bring a bag when you shop for groceries. Bring a water bottle instead of buying bottled water. Use your own container when you are having a lunch. There are many ways to cut our use of plastics, starting today and save our planets together. Thank you.